Well, good morning, good afternoon again. Welcome to our next panel discussion on future connectivity. And we're going to be talking on the subject of security. Data link connectivity certainly provides some opportunities for innovation and maintaining safety, but the reliance purely on that connectivity can also have some security issues that need to be looked at. And any system, of course, is only as secure as its weakest link. So further collaboration across the industry is going to be really essential. We need to define and address some of the main risks and issues that have to be dealt with. And there's definitely a need for the aviation industry and all the aviation stakeholders to assess, identify, and learn how to mitigate some of these risks and issues. Just as a reminder, before we get started, you can submit questions to the panelists today on the Q&A tab. The recording of the session is going to be available in the events lobby through November 24th, and speaker information can be found on the speakers tab. For those of the speakers that have given permission to share their slides, they're going to be available in the events lobby later today. So, protecting communications in an unsecure world. I'm going to turn things over to our moderator for this session, Mr. Timo Worms from Airbus.
Thank you very much, Terry. Welcome, good morning and good afternoon, everyone. I'm happy to be with you today and to moderate this panel on the security of future connectivity. And thanks to RTCA and EuroKE for providing the opportunity of having this panel. Let me give a short introduction to the subject. As presented in the previous panels, future data link communication has different drivers. So, for example, including IPS, the Internet Protocol suite, and also evolving radio technologies for the air-ground links. So with IPS, data link communication will be based on the Internet Protocol, so essentially the same technology that is used by the public Internet, for example, also for this panel meeting. In terms of air-ground links, future data link communication may rely on some completely new technologies like LDACs or Aeromax, or what is termed hyperconnected ATM may also use commercial links, which so far have not been used for data link communication. And finally, data link future data link may rely on already established means like VDLMO2 or SATCOM Class B, which evolved to meet the needs of IPS. So overall, data link will undergo quite some changes, which also imply changes to the threat surface of data link. So future data link will be subject to new security risks, which deserve appropriate protections. So I'm very glad that we have three great panelists who will introduce and discuss with us protecting communication in an unsecure world. Let me first introduce Craig Boxrucker from the Airline Pilots Association's ALPA. Craig is a B737 captain with Alaska Airlines with over 16,400 hours. And he's also the vice chair of the Air Traffic Services Group of ALPA's Air Safety Organization. Craig has a background in engineering with a bachelor degree in aeronautics and a master's degree in mechanical engineering. Then we have Peter Leidold. Peter is leading the market unit network solutions at Frequentis. Frequentis delivers network solutions to ANSPs for more than 20 years now. And research in this area, in the area of future data link, is a very, very important part of it. Peter has a background in systems engineering with more than 20 years of experience in the ATM sector. And finally, we have Jonathan Gravey from Collins. Jonathan is a principal network and systems engineer at Collins Aerospace Connected Aviation Solutions, so what used to be ARINC. And Jonathan has a background in telecommunications, being a professionally licensed engineer with a master's degree in telecommunications management. And he's also a published author on topics of cybersecurity, network mobility, IP address structures, and transactional security. Also, congrats to Jonathan for being the Collins 2023 Engineer of the Year. So we will proceed as follows. Each of our panelists will give short presentations with his views of protecting future connectivity. And then we will have a debate and a Q&A session. So we start with the presentations, first with the presentation of Craig. Craig, over to you. Thank you.
Thank you, Timo. Thank you, everyone, for joining us, and good morning and afternoon or evening, wherever you may be. So essentially, the trust is the foundation for pilots. We also verify, so it's a cooperative type of a agreement, trust and verify. To this end, ALPA supports a CPDL system that attains and maintains performance standards. There's a number of things we're trying to reduce: read back, hear back, and data entry errors. Also, we would like old message recall. There's multiple layers that allow for redundancy. There's a number of systems, excuse me, within the within an aircraft and within the system that allow for this redundancy and sort of layering of redundancy throughout the system. And having multiple layers of voice and CPDLC, it just increases the safety. But essentially, we're here to discuss the secure channels of communication. And to attain this, these secure channels of communication, we're looking for commonalities and similarities between voice and CPDLC. This allows for the pilots to have identify unauthorized controllers when they show up. Allows for the unfamiliarity with voice phraseology by a rogue entity to show up and be detectable by the pilots. CPDLC needs the ability to provide the protection from unauthorized messages coming up or down from the aircraft. Next slide, please. So pilots are trained to, like I said at the onset, pilots are trained to trust the system. They have equipment or system failures that could lead to a lack of trust. Alerts are needed to maintain this trust. These alerts could be in the form of just a simple auditory or a simple scratch pad message on our FMC. And this allows for pilots to have the procedures to manage these malfunctions or manage a situation that may arise. Alerts lead to verified methods of management. This allows for a pilot to not troubleshoot the issue, but to focus on procedures and training that they've had in the past. Another thing that CPDLC needs to do is provide protection for itself in the ground, CSPs, and avionics. Protection from cyber attacks, the man-in-the-middle, denial of service, and radio frequency jamming, etc. Pilots also must be able to be alerted and identify and rectify a cyber threat. Next slide. To provide an example of how trust that could be lost in the CPDLC world. In the recent past, we've had a number of occurrences where the message sets have led pilots to maybe not trust the system as well. An example is the UM79 message. The history behind this is it began with incompatibility with DCL, which is the ground route clearances or reroute clearances with some of the avionics systems that we have. There's errors that did occur, and this required some manual entry. Then this required additional significant training and educational investment by operators and pilots. So with these messages that occurred at the DCL level, which is the ground clearances and reroutes, there began a little bit of an insidious little mistrust in the system. The UM79 messages beginning in en route clearances, message sets relied solely on executing via a load prompt on our FMC. However, with the manual entry prevalent in the system, because of the ground errors or the ground errors that were created over a period of time, this caused the errors in the en route system, which created some issues for pilots, and then it created some errors along the way as well. There then had to have another additional educational and training investment for the pilots going forward. So so pilots lost trust in the system in general just by going through these different avenues of different types of entry of clearances. So in essence, for pilots need to be able to trust the system from a standpoint of be able to see that the message that comes up from them is and be able to execute properly within their systems they have. So so that's all I have for my presentation. Back to you, Timo.
Thanks you very much, Craig. These are very interesting insights regarding the crew perspective on security for future connectivity. We continue with the presentation from Peter. So Peter, over to you.
Thank you, Timo, and also welcome from Vienna, Austria. So Frequentis is coming from the ground industry in air traffic management. So what we are doing is providing network solutions for ANSPs, especially interconnecting the different facilities and having the most critical applications on it. Is it voice, is it surveillance, and many other data applications. And as you can imagine, security is a big topic in there. In the recent years, we have become more engaged also with the topic of the data link and the future communication infrastructure, because these networks are getting now more and more interconnected. So our main project is the CESAR future communication infrastructure, where Frequentis is the solution lead, where we are providing a validation system to validate the different data link technologies, to validate how they can work together when it comes to multi-link, when it comes to mobility, and security is also a core part in that. Frequentis is also very engaged in the standardization, ICAO, IPS, LDAC standardization, and many other air traffic management topics. Coming from the ground side of things, what we have seen in the recent years is actually a huge amount of different regulation and standards when it comes to security. So when we look at the requirements of our customers, mostly NSPs, it's very difficult on how to handle it. So you have national regulations and standards, you have international ones, you have industry domain specific ones. I think this ongoing activities now also to get guidelines from ICAO, also European RTCA, is a very important move forward. What we also have to recognize, the current data link technologies are more message-based technologies with low bandwidth, with proprietary technologies. So the exposure to threats is more limited, I would say, and more related, and the fact is more isolation to protect from it. In the future, surely, when we move to high-speed data links, when we move to IP, the end systems, the ground infrastructure, the airplane, and everything related to it is getting more interconnected and more vulnerable in this sense. So we need to apply here a multi-layered approach. Next slide, please. I will talk here about the data link security, and I will use LDACs as an example. But to give you first a quick introduction what LDACs is about, LDACs is the next generation terrestrial data link, which you can see here as a big evolution from VDLMO2, which typically has a shared bandwidth of 30 kilobits per second. With LDACs, we move up to 2.6 megabit per second. It's an open standard. It's specifically designed to efficiently use the L-band, to also use more or less unused spectrum at the moment. It's an essential part of IPS IPv6, and as mentioned beginning, part of this future communication infrastructure research. It's specifically designed for the aeronautical communication. I mean, it's based on LTE 4G, but the properties have been adapted to the high speed to allow these large coverage areas of 200 nautical miles. And also to guarantee especially the performance and the quality of service. And that's an important factor when it comes to trust to the system. There has been flight trials last year, probably 1 year ago, in Germany with DLR, where also the different concepts has been verified. The biggest challenge for sure for LDAX is that at the moment the ground radios are available, but the aeronautical radios are not yet available. So for this flight test, ground radios has been used more or less. It supports a cellular concept, and it's well reflected in the ICAO standardization and communication standards. Next slide, please. So when we look now at data link security in general, so as mentioned already in the beginning, we want to have a multi-layered security approach. So we will have the end-to-end security, which is closer to the application, where Jonathan will talk about it. But on top of that, we will also have the data link security. And LDAX, in this sense, is now, you can see as an example, the same paradigms we have to and want to apply to all other data link technologies. So first, we can have a look at the ICAO standards, the ICAO 9896 edition 3, which is a good baseline, and it has three simple requirements. What we want to make sure that the airborne users are authenticated and authorized, but also that the ground data links are authenticated and authorized. So we really want to make sure that only authorized participants can communicate. And the third requirement, we want to make sure that what is communicated, so the messages have integrity, and we only exchange authorized messages. So it should create a very secure environment. So how is LDAX doing that? We have three components in there. The first one is the trust infrastructure. So we need more or less a public key infrastructure, PKI infrastructure. And to make things more simple, it doesn't need to be a fully dedicated one, but this can have shared components, which surely we'll learn later from Jonathan with the IPS end-to-end security. It's also important and this is in there that we can exchange certificates. We will have certificates that last probably 1 to 2 years on the airplane, but on the ground infrastructure we will have a much lower, much shorter time for expiration, probably in the range of days. Yeah. So the next thing is the cell attachment procedure. So we want to now make sure that both the airplane authenticates to the ground infrastructure, but also the ground infrastructure authenticates to the airplane. So we want to have a mutual trust relationship. And the important part here is, although we are having now higher bandwidth available, we still want to make sure that the security message exchange is on a reasonable level. So we don't exchange authentication for every ground station when it comes to LDAX, but the airplane will authenticate, for example, to a LDAX ground system, which can be an LDAX provider, but which could be also like an LDAX region. Yeah, the last thing is, sure, integrity and encryption is a big topic. So user and control data protection. At least we want to make sure that the integrity is good, because for certain application we might not want to allow encryption, to have more transparency, but encryption is also a possibility in LDAX. LDAX also not only provides user data protection, but also control data protection. So there are control messages, for example, to reserve bandwidth or to provide bandwidth, and others are exchanged between the ground radios and the airborne radios, and this is protected as well. So in a nutshell, we want to have a multi-layered security approach, starting with the data link, going to the application security. Jonathan will talk about it. And last but not least, as mentioned in the beginning, also the human factor is a very important one. So the pilots and the ground operators also need to be involved to make sure that the security is maintained. Okay, so thank you very much from my side. Then I will hand back to Timo.
Thank you very much, Peter, for this insight on the radio side of things, in particular LDAX side of things. We continue with Jonathan. So over to you, Jonathan.
Thank you, Timo. The industry is well aware of the loss of confidence in the risk of loss of confidence in safety communications, is well captured in the previous presentations, adding to the stress of otherwise multitasking pilots in performing to the best of their abilities to maintain safety of flight. The industry also has concerns as fleets move towards pilot off-board and as the air traffic controller shortage becomes more pronounced. Flight corridors become more congested, meaning that more digital-based messaging will be required to maximize the efficiency of both the pilot and air traffic controllers while improving confidence in safety communication. Next slide, please. We today have a couple of protocols used for safety messaging to aircraft. ACARS was deployed in 1978 by ARINC, was deployed globally for AOC and ATC messaging. The early 2000s, through the careful consideration of ICAO, the Aeronautical Telecommunications Network, ATNOSI, was invented and deployed in most of Europe. These protocols do well to coordinate air traffic control and AOC operations, but as of late have become a limitation on new entrants and new concepts, as the new entrants may have limited ability to support multiple protocols. So to evolve into the next generation, the industry is developing the Internet Protocol Suite for Aeronautical Safety Services, we all calling IPS. This is a collaborative effort between many industry entities and is defined by ARINC AWC 858. The MASP is an RTCA DO404, which is cross-filed as EuroK ED315, and ICAO has updates to 9896 for the support of IPS. This protocol will require both the secured use of radio access layers, as Peter had had demonstrated previously, and also provides for end-to-end application security, ensuring that the aircraft can authenticate the AOC or ATC entity that it is communicating with. Messaging sent through IPS service can be checked for integrity and non-repudiation, meaning the signature of the message can be verified as coming from the source the message claims to be from. Next slide. Sorry, let's stay here for a second. To maintain the security of IPS, a collaborative effort is required between the OEMs, the avionics manufacturers, the ACSPs, CSPs, AOC, and ATC operators. The Trust Framework Panel of ICAO is working to define the trust relationships using zero trust methodologies, coupled with standardized auditing for security as well as safety. Aircraft will have long-lived identity certificates, which authenticate themselves, the aircraft, to ground entities. And ground entities will use short-lived certificates. The ground providers can provide assurances to the aircraft of the validity of the ground certificate by stapling an OCSP response when presenting the server certificate to the aircraft. This alleviates the aircraft from having to do certificate validation of the server certificate through an automated process. Next slide, please. IPS is based on the IPv6 protocol with some enhancements for aviation, ensuring protected communications. ACARS and ATM messages can be encapsulated inside of IPS to benefit from this enhanced security. IPS will further enable new entrants such as steerable balloons, UAS, UTM, RPAS, and other future aerosystems to interoperate with legacy systems. The Industry is developing interconnectivity between traditional ACARs, ATN, and new IPS systems, making it possible to maintain ground-based ACARs and ATN OSI deployments while leveraging IPS-enabled aircraft. If we examine the IPS MASPs, the responsibility for IPS is broken down into different components. I'll focus in on the air host and the ground host. Air hosts and ground hosts are responsible for establishing a secured DTLS session between themselves, independent of media, DTLS being the UDP variant of TLS. This means that the aircraft, as the aircraft switches media, the application level traffic connection remains intact. To reduce the number of DTLS sessions required by the aircraft, it is encouraged that the ANSP operators directly utilizing IPS have a centralized point or cluster where these secured sessions can be terminated. Controllers or operators can then hand off the connection to other controllers, providing for seamless handoff without needing to reestablish security. Both the FAA and several European ANSPs are exploring this model. Next slide, please. The industry is pushing forward with the IPS design and testing. The first eco demonstrator flights, that's a Boeing test flight, was a set of flights, one of which was a circular path from Boeing Field via Salt Lake City, Moses Lake, and back to Boeing Field. These flights demonstrated IPS over VHF and SATCOM. The aircraft with an IPS updated avionics had successful FANS 1A, CPDLC messages exchanged using IPS with the FAA Tech Center by an IPS ACARS gateway. Additionally, an ADS-C contract was established with reporting over IPS. AOC messaging were exchanged with Alaska Airlines via an IPS ACARS gateway. Further, B1 CPDLC messages were exchanged with the ground test system via IPS. These tests went extremely well and proved that IPS is a viable concept, but requires some additional evolution. The second test, a very large-scale demo, is sponsored by the FAA with many participants. This time we are to ensure that different industry partners' implementations are interoperable, identifying any additional requirements outside the standards, but necessary for implementation, as well as points where clarification is needed in the standards. We'll perform these tests via connected labs, leading to real flight tests using the Boeing Eco Demonstrator System. Tests include IP mobility, that's IPv6 mobility, VDL security using signed message integrity code, certificate verification using OCSP with trusted responder, full certificate path verification, CA issuance of certificates, native IPS, ACARS in IPS, and penetration testing. The VLD will have a greater focus on the validation and security architecture. The goal is not only that we are all interoperable in our respective domains, but with each other to de-risk IPS deployment. We also hope to show the system is resistant to penetration attack. Next slide, please. It is very important to emphasize that nothing is changing for legacy ACARs and ATN OSI over VHF. IPS is an additional network which will support all current applications, fully interoperable with existing ACARs and ATN OSI systems. What is being enhanced is that access to IPS will require mutual authentication between communicating peers regardless of media type. The IPv6 mobility will be deployed, which opens the door for multi-link and hyper-connected aircraft, allowing for all available connectivity paths for different data flows. Further, compression will be brought online to reduce the amount of RF time required to transmit the message overhead. And VHF will be updated to provide security for IPS traffic, usage of message integrity code to protect traffic in transit between the aircraft and CSP, and the industry standards that IPS brings the IPS header and the DTLS overhead into the RF space. And we as an industry are working to reduce the amount of additional frequency on time required for such overhead. Next slide, please. To wrap up, I'd like to say that the future is bright for the industry and pushing ahead to adopt to both the new entrants and to alleviate pressures on ATC operators. We're rolling out a new technology IPS, which will further enhance ground-to-aircraft communications allowing new participants to engage and interoperate in this space. Security is being enhanced for IPS, requiring multiple layers of authentication and integrity checking. And we're doing all this without the need of a heavy uplift of the ANSP or AOC operators who can maintain their existing backend systems and processes. This will further also increase the level of confidence in safety communication. I hope you can see that the industry is listening and evolving to the needs of the aerospace users. And back to you, Timo. Thank you.
Thank you very much, Jonathan. I would like to now invite all the panelists to the stage for having the debate and Q&A sessions. Of course, we encourage the audience to raise questions, and I will be glad to relay these questions to the panelists. However, just to get started, I noted down some questions myself, so let's maybe get started with them. Craig, maybe first question for you. When doing the security engineering of a new system, one of the very first steps is to identify the relevant threats that one needs to protect against. Of course, this also holds when developing and defining future connectivity systems. So from your perspective, which kind of threat landscape should be considered for defining and developing future connectivity?
Well, thanks, Timo. I think from a perspective of aviation, we've had fewer avenues for what do you call it, injection or a cyber threat of some sort. IT world in general has had a lot more, a lot more avenues, and they have the experience of detecting and mitigating cyber threats. So taking a piece or a training or educational background from the IT world would probably be helpful. Jonathan is in his presentation showed a number of avenues they've worked on at Collins that have provided the knowledge from the IT world and allowed for us to educate ourselves in the aviation side as to what we should be looking at in the landscape. So.
Yeah, thanks a lot, Craig. So I think this is a very interesting observation. So the IT world, of course, has been way more exposed to security threats, to information security threats, and at least to some degree, this with future connectivity moving to the internet protocol, we are also changing the threat surface. So we should learn from the IT world and apply appropriate protections as are well established in other domains.
Yeah, and Timo, and the other thing too is that since the aviation world is becoming more interconnected through apps on our EFBs, connecting different sources of data. Just looking at the aircraft from generations ago, the aircraft has in general has upgraded itself and possibly allowed for more avenues for rogue entities to come in and disrupt what we're doing on the flight deck. So protection from these new avenues and learning, like I said, from the IT world would be highly beneficial. And I think, like I said, Jonathan has a great presentation, and he could maybe speak a little bit more about this.
Yeah, understood. Thanks. Then maybe Jonathan, so in the aviation world, we now have quite a number of security initiatives running. So just to name a few, we have at ICAO level, the Trust Framework Panel, the Cybersecurity Panel, and also the Working Group I activities working on future connectivity. Then we have other standard developing organizations like, of course, RTCA and EuroKE with SC216 and Working Group 72, as well as the groups working on future connectivity, SC223 and Working Group 108, and other bodies like Aviation ISAC, the European Center for Cybersecurity and Aviation, AWC committees, for example, the recently established AWC Cybersecurity User Forum. So we have quite a number of initiatives and forums now working on security. This, of course, bears the risk of being misaligned, have some misalignment between different bodies if it's not well coordinated. So can you share some insights on how the work on security of future connectivity is organized across these bodies?
Thank you for the question, Timo. And initially, I was actually very concerned as well, seeing that all these different groups are being spun up and trying to solve a different aspect of the security concern. One of the things that's very positive that's happened in the last 2 years is that ICAO has really stepped in through a panel that they've created, which is called the Trust Framework Panel, to kind of architect and oversee some of these groups that are working on specific problems within the security landscape. And if I can highlight a few of them, so TFP is looking more at the not only the PKI infrastructure and how that's going to be set up, but also into the governance organization and how that would how the auditing of that particular PKI and the usage of those PKI certificates be maintained in a way that's safe and for in a way that the aviation community can trust each of those certificates. So there's that. There's 2 other ways that we're actually coordinating together, and that is one through champions. There are a number of us, yourself included, that are attending multiple of these committees, and we're trying to bring in the ideas of all of them together so that we don't stray apart as all the committees try to work on their individual topics. And finally, we also actually exchange the paperwork, even in draft form, between all the different committees from ICAO all the way down to like an AWC type committee, so we can all kind of work towards all of the same problems and solve them in a way that is compatible all the way through the chain.
Yeah, thanks, Jonathan. And also what I remember from different discussions is that in different bodies, we often had discussions like, okay, this topic belongs or better belongs to this other body, so we need to shift this topic to another body. And from my perspective, also, this was quite well coordinated and an action was taken to bring this particular question to another body where it's discussed more appropriately. So I fully share your view, yes. Now, beyond standard developing organizations, I mean, we have many stakeholders involved in future connectivity. So it's not only the standard developing organizations, but we also have pilots, so the crews, aircraft operators, aircraft OEMs, communication service providers, ANSPs, controllers. But at the same time, security is a weakest link property. So when you compare security to a chain, it's only as strong as its weakest links. So protecting future connectivity then obviously is a shared responsibility where every stakeholder needs to contribute. So Peter, maybe you can share some insights or your view. How is or should this sharing of responsibility be organized?
Yeah, that's a very interesting question. And I have to say also, having worked in other industry, for me, the aviation industry is a prime example on how collaboration can work and should work. So first of all, I'm very confident that this topic is managed successfully. I think there are all tools available already today when we think about the standardization groups, when we think about the user groups, when we think about interoperability testing. So this is one of the my biggest learnings when I have the first time attended the ED137 EUROCAE interoperability testing, where you get together all different angles of the industry and they look at the things work together. And I think these concepts we also need to apply to security and maybe even to extend it because security is not only is not a specific topic in aviation, but applies to other critical industries as well. So probably we should here also engage with other industry. Is it public safety? Is it the power grid distribution, things like that? And I think what we could also use to our advantage, we have, when we look at the different parts of security, we have different speeds. the ground's infrastructure can be much quicker to respond to security threats than when we look at the airplane side of things. So there are much shorter cycles where we can update software, where we can change architectures. We will see how this changes with the ground system certification, especially in Europe. But I'm still confident that we will manage through that. But what I also see is there is a strong focus on technology, on technological solutions, and maybe we should shift or shift the discussion also to stronger towards processes and the human factor in security, which is the most important part in my opinion.
Mhm.
Yeah, I think that's it from my side.
Yeah, so thanks, Peter. Maybe also one interesting aspect, in particular for the IPS, was the development of the MASPs. So RTCA and EuroKE have recently published the MASPs, so the minimum aviation safety and performance standards, where also some shared responsibility was defined in terms of security. So there are requirements included and allocated to the different stakeholders. So I think that's also one interesting element to consider and to see whether this could also be a model for other areas of communication, navigation, and surveillance. Thanks, Peter. So I have one further question for Craig. So Craig has presented his views on the crew perspective on security, has presented that alerts are essential for the pilots to maintain trust in a system. And assuming the same holds for the controllers on ground as well. This is at least what I assume. So maybe we can have an illustration on this for a security threat. So Craig, can you guide us through this? So for example, let's assume that data link communication cannot be established, maybe due to a denial of service threat running inside ground networks. So how could the alerting and mitigations by pilots and controllers look like for such a case?
Well, there's for the alerting side, there's going to be a cannot or should not level of communication establishment. So cannot is one thing we currently have in the aircraft. If we cannot log on to a CPDLC for a CPDLC connection, we get an alert via our FMC, FGM, FMGC, or other avenues. We have some kind of alert that allows us to see that it cannot be established. Should not is a different story where there may be an IT issues with a ground-based or a network or might be a rogue entity transmitting or blocking signals and that kind of, and we should not try to establish. And that could be alert via a NOTAM system that allows us to see in advance, or it could be where we don't get an alert, but there should be some kind of a process on the ground where any kind of incoming handshake or message or request for connection is denied, and network connections are cut off, and so to speak, via a ground-based sort of system of verification. So in essence, it should be there should be an alert on the aircraft if we cannot do it, or there's a uplink message that does not pass that authentication process, and there should be a avenue on the ground that prevents us from connecting. We would get the subsequent message coming up that unable to establish connection on our aircraft. So there can be a number of different ways to look at how we're alerted. They may be the same type of alert. They're just simply saying that the connection should not or cannot be established. It doesn't have to be specific to the pilot. The pilot doesn't need to know if it should not be connected or cannot be connected. It just needs to know that it's not connected in that aspect. So.
Yeah, thanks a lot, Craig. This clarifies things. Yes, thanks a lot for these insights. We have a question from the audience, so I will relay. So will VDL support IPS, including sufficient or desirable security mechanisms? So maybe Jonathan, this could be a question for you, right?
Yeah, thank you, Timo. And this is certainly something that's been a matter that I've been researching, coming from the former ARINC company. And what we have found out is, yes, the IPS can be supported by VDL, and VDL, we're actually rolling out a security mechanism for VDL to protect IPS in its transit from the aircraft to the ground. So that was rolled out in the original eco demonstrator, and we will also roll that out for the next VLD testing to further flush out that security mechanism. And that kind of tied into my need for reducing or compressing the kind of overheads required for security and for any of the IPv6 or UDP overhead. So we're also investigating that as well. But so far, the answers have been very promising.
And then also to maybe to emphasize, so the idea would be indeed that IPS communication runs over secured radio links. This includes the legacy links. So VDL, what I maybe briefly mentioned initially, even VDL Mode 2 will evolve to support the needs of IPS, and this includes security, right?
This is correct.
And maybe this brings us nicely to another question I had for Peter. So we have different radio links available for future connectivity. So Peter has you shared some insights on LDACs and showed how LDACs will be secured. Another concept or another potential link is what is hyperconnected ATM. So using commercial links for data link communication. So these are commercial open world networks, which may bring particular challenges for security. I mean, the threat surface may be quite different for these commercial networks versus the more classical aeronautical networks. So Peter, can you share some insights on what does this threat surface look like and which kind of protections would be needed?
Yeah, so that's a very interesting question, and let's put it that way. The good news is, so hyperconnected with its technology, is it 4G, is it KU, K-band satellite, or whatever is also used for the passenger internet connection, provides a great opportunity, a great cost-efficient opportunity. And the second good news is the requirements we discussed before on LDACs and the concepts applied to it can be used for any other technology. So it can be also applied to hyperconnected technologies. Sure, the problems and the challenges are on commercially available technologies. It's much harder to get the quality of service guaranteed. So it will be, in a sense, not as predictable, which is something that needs to be managed. And also the attack vectors are very different ones, because we talk about publicly available networks. So yeah, even potentially the passenger or somebody else connected in the same network would be able to interfere here. But I think, how can this be addressed? So first of all, we probably should look into what applications we want to put onto this type of networks. So probably not the most critical ones, probably not CPDLC, but probably some data of the airplane that goes in a one-way direction. So this could be a kind of selection of the applications. But surely also these commercial technologies could be a last resort in a sense. But with the possibility of special monitoring or the ability of the pilot, if things look strange, to turn it off, to disconnect it. Yeah, also the question is where these VPN tunnels, for example, that you still will establish, will terminate. So will it terminate in this commercial equipment router, or will it terminate in the airborne router? So I think, and that's probably also a question of certification. So I think here there are a lot of options to deal with that. Okay, I think that's it.
Yeah, thanks, Peter. Thanks, Peter. Maybe also closely related to this one. I mean, we have seen that LDACs will be protected using digital certificates. As Jonathan has presented, IPS will be protected using digital certificates and maybe hyperconnected ATM in the future as well. So all of this is based on digital certificates, which have an expiration date. So they need to be maintained over time. And this, of course, is associated to maintenance efforts. So I'm wondering what kind of costs are associated in terms of maintenance with these new security mechanisms. So which kind of efforts will be needed by operators to support these upcoming security features? Maybe Jonathan or Peter, maybe Jonathan, you want to start on this one?
Sure, I can give that a start. So there's really two levels of this to answer this question. One is with the trust anchors themselves, that being the CA root certificates, the public certificates. And because those are the root of trust, that's going to have to be maintained on the aircraft through a maintenance function. The good news with that is those root certificates are not set to expire for many years. So we're not expecting a lot of maintenance to be added. In fact, this probably can line up with an existing maintenance cycle that the airlines are already doing. What becomes a little more interesting is the individual aircraft certificate, the identity certificate, if you will, which will also be on the order of years. It can be loaded through a maintenance action because we're kind of expecting airlines to be putting hands on their aircraft at least once a year, hopefully more. But there are other features being explored, like kind of an over-the-air type of key management type thing. That is still to be flushed out, but certainly something that is undergoing some discussion at the industry level. I'll return it back to you, Timo, if you want to bring in Peter.
Yeah, Peter, go ahead.
Maybe I would like to add maybe here another dimension, and so probably certificates also should be the different technology side topics. So it should be coordinated between the different link technologies. But I think a very interesting question, and that would be also what certificates means in terms of geographic areas. So as we know, the world is at the moment, there are different regions in the world, and probably there need to be certificates systems depending on the region and the political situation.
Yeah, thanks, Peter. And maybe to complement on what Jonathan said, so yes, there are new protocols, new means for over-the-air management under investigation. So ideally, many of these elements can be automized, so to reduce maintenance overhead as much as possible, I would expect. We are hitting the end of this panel, unfortunately. I would like to thank all the panelists very much. Thanks a lot for your insights, for the discussions. And with this, I'd like to hand over back to Anna.
Thank you, Timo, and thank you to all panelists, Peter, Craig, and Jonathan. I think this was a great panel that highlighted that both in the end, on the ground, some of the risks and vulnerabilities and some possible mitigation that one needs to think about in the context of future connectivity. See what we can learn also from other industries. Quite some great thinking impulses for that. So thank you very much again, Timo from Airbus, Peter from Frequentis, Craig from ALPA, and Jonathan from Collins. I'd also like to thank again our sponsors, ALPA and L3Harris. And I'd like to remind all of you that the recording of the session is available in the events lobby for a month now. As well as our pre-recorded on-demand sessions, which are available through rtca.org on AIS Med Datalink services, air traffic data communication services, security, and IPS. And please join us for the next session going through the events lobby. We will begin at the top of the hour.